Something moves through the grass. Too small to cast a shadow, too quick to follow, gone before the eye can settle. Most of us walk past this world every day without a second glance. And that, in a way, is exactly what it counts on. This is the world we are about to enter. Look down, not at the horizon, not at the canopy overhead, but at the ground beneath your feet, at the patch of bark on the nearest tree, at the leaf edge catching the light. That is where this story begins. The jumping spider does not wait. While most of its relatives hang motionless in silk, trusting geometry and patience, this one walks, stalks, turns its head to examine something that caught its attention a moment ago. There is a quality to its movement that is difficult to name. Not quite hesitation, not quite confidence. Something between the two. Thousands of species carry this family name, spread across nearly every environment on Earth. Some are so well camouflaged against bark or stone that finding one feels almost accidental. Others, particularly in tropical regions, are almost absurdly vivid, patterned in ways that seem to belong on something far larger. The variety is enormous, but one thing connects them all. Those eyes. The large front-facing pair gives the jumping spider something genuinely unusual in the arachnid world. The ability to see in sharp detail, at close range, in full color. Most spiders navigate primarily through vibration, through the tremor of a web. Jumping spiders watch, they track. When one fixes its gaze on you, there is an unsettling sense that something is actually looking back. During a hunt, that gaze becomes a tool. The spider spots prey, pauses, and begins to reposition, slowly, without rushing, until the geometry feels right. Then it moves. The leap can cover many times its own body length, precise enough to land directly on a fly or beetle. Before leaving the surface, it attaches a thread of silk behind itself. A safety line, almost incidental, released without breaking stride. In Australia, the males of one group, the peacock spiders, take this further. During courtship, they raise their legs and fan out sections of the abdomen that carry patterns of extraordinary color. Blues, oranges, iridescent greens, arranged in forms that seem almost deliberate. The display is performed for a single female a few centimeters away. At that scale, it is one of the most elaborate performances in the natural world, and one of the easiest to miss entirely. But perhaps the most unexpected thing about jumping spiders has nothing to do with color or precision. Researchers have found that some species, when direct access to prey is blocked, will move away from their target, lose sight of it entirely, and navigate toward it from a different angle. The spider is not reacting to what it sees in the moment. It has already decided where it needs to be. For an animal measured in millimeters, that is a remarkable thing to carry inside such a small head. And yet, in this world close to the ground, the jumping spider is far from alone in its sophistication. At first glance, it looks less like an insect and more like part of the flower itself. The orchid mantis lives among the forests of Southeast Asia, where appearance can be as lethal as any weapon. Its body carries shades of white, pink, and pale purple. The legs broaden into petal-like lobes, dissolving the boundary between animal and plant. To a passing bee or butterfly already drawn toward color, the distinction barely registers. This is camouflage taken somewhere unexpected, not concealment, invitation. The orchid mantis doesn't disappear into its surroundings. It becomes something other animals actively move toward. Yet color is only one solution. Far from the brightness of tropical petals, another species has gone in the opposite direction entirely. The dead leaf mantis is exactly what its name suggests: flattened, uneven, edged with the irregular outline of something dried and discarded. Browns, dark ambers, the occasional streak of near black. Nothing about it suggests life. Even its movement plays a role. Traveling through vegetation, it sways faintly, mimicking the drift of a leaf in a breeze. Stillness alone isn't always enough. Sometimes the disguise only holds if the whole body behaves like the thing it's pretending to be. One resembles a flower, one resembles debris. Both are hunting. Most mantises, though, are neither pink nor brown. The green mantis that turns up in gardens and grasslands across much of the world looks straightforward by comparison, and in some ways it is. But its behavior is harder to dismiss. Unlike most insects, it can rotate its head to follow movement without shifting its body. Watch one long enough and something feels different about it. Less automatic, more considered. Those large, forward-facing eyes give it genuine binocular vision, the ability to judge distance accurately, which matters when your strike has to land in a fraction of a second. The forelegs, folded beneath the body in what inspired the name praying mantis, are built for exactly that moment. Lined with sharp spines, driven by muscle capable of moving faster than the eye can follow. What's easy to overlook is how early all of this begins. When young mantises emerge from the egg case, they are already recognizable, small, complete, unmistakably themselves. No larval stage, no intermediate form. The adult is already there in miniature from the very first day. Flower, dead leaf, or motionless green stem, each a different answer to the same problem. What's striking is how many answers there turn out to be. Not every insect hides. Some make an entrance. The Carpenter Bee arrives with a buzz you feel before you hear it. Low, resonant, the kind that belongs to something bigger than you expected. Catch one in the right light, and the wings shift with an iridescent sheen that seems almost out of place on an insect. For a moment, it looks less like a bee and more like a piece of jewelry that got loose. Despite the resemblance to bees most people know, the Carpenter Bee operates on entirely different terms. No colony, no queen, no shared comb. Each female builds her own nest alone. Not by gathering material, but by removing it. Using her jaws, she cuts directly into dead wood or bamboo, carving out a tunnel where her eggs will develop. The result is hidden inside the timber itself, invisible unless you know to look. For their size, carpenter bees are surprisingly unhurried. They move between flowers at what seems like their own pace, hovering briefly, drifting on, occasionally pausing in midair as if reconsidering. Calm is the word that comes to mind. Purposeful, but calm. The honeybee works on a different scale entirely. Individually, a honeybee is easy to overlook. A few millimeters of wings and instinct, gone before you've properly registered it. But step back and look at what tens of thousands of them produce together, and the picture changes completely. Inside a hive, no single bee understands the whole operation. There is no manager, no blueprint pinned to the wall. Workers clean, feed larvae, store food, control temperature, and guard the entrance. Each responding only to immediate signals, with no sense of the larger system they're maintaining. And yet, the system works. When a forager finds a good source of nectar, she returns to the hive and dances. Not metaphorically, literally. The waggle dance encodes both direction and distance, giving other workers the coordinates of flowers they've never visited. In the dark interior of a hive, information travels as movement. The comb they build from their own wax has puzzled engineers for a long time. Hexagonal cells packed together without gaps use the minimum possible material to create the maximum possible space. It is a very elegant solution, arrived at without a single calculation. What's hardest to grasp is the timescale. Individual bees live only weeks. Generations overlap continuously. No single worker will ever see the colony complete. And yet, the hive persists, not despite the turnover, but somehow because of it. A carpenter bee works alone and builds something that lasts a season. A honeybee is one of 50,000 and builds something that outlasts them all. Among the flowers where both of them feed, another chapter of this world is already beginning. Near ponds, rivers, and quiet stretches of water, a different shape patrols the air. A dragonfly rarely seems in a hurry. It glides, pauses, changes direction, then drifts onward again. From a distance, the movement looks effortless, almost weightless. Dragonflies are easy to think of as a single thing, a flash of wings above a pond, a silhouette crossing the water. But look closer, and the variety becomes difficult to ignore. Some are electric blue. Others glow red, green, gold, or almost metallic in the sunlight. Even among insects, the range feels unusual. Yet beneath the colors, the shape remains instantly familiar, a design that has endured for far longer than the landscapes we know today. These insects were already here long before grass covered much of the land, long before most familiar animals existed at all. The ancient relatives were larger, but the blueprint has barely changed. Slender body, transparent wings, and eyes that take up most of the head. Whatever this design is doing, it has been doing it for a very long time. Those eyes are worth a moment's attention. Thousands of individual lenses, covering almost the entire surface of the head, feed into a view of the world that is difficult to imagine from the outside. Not just wide, genuinely panoramic, tracking motion from nearly every direction at once. A dragonfly doesn't need to turn to know something is moving behind it, which may explain why they seem so permanently alert. Hovering above the water, inspecting a reed, circling a patch of open air for reasons that aren't immediately obvious, then gone, across the surface before the eye can follow. On warmer days, one might settle on a stem and stay there. Wings open, still, catching whatever light is available. The water below reflects the sky. For a moment, nothing moves. Then it lifts, and the pond returns to its usual business. Season after season, dragonflies come back to the same stretches of water. The individuals change. Most adults live only a few weeks, but the pattern holds. Something about that quiet persistence, repeated across every pond and river on Earth, is quietly extraordinary. Across the surface, one passes another. Ripples spread through the reflection below, and somewhere beyond the reeds, another story is already waiting. Across the surface, one passes another. Ripples spread through the reflection below, and somewhere beyond the reeds, the variety of this world continues in directions that are harder to anticipate. Some of what lives here resists easy description, not because it is hidden, but because nothing quite prepares you for it. The giant centipede moves across the forest floor with an unsettling smoothness. Dozens of legs, working in sequence, producing something that looks less like an animal navigating terrain and more like the terrain itself shifting. Every limb knows its place. Nothing hesitates. Elsewhere, a caterpillar goes still. For days, sometimes weeks, it disappears inside a chrysalis, sealed off, inaccessible, apparently doing nothing. What actually happens inside is one of the stranger processes in nature. The caterpillar essentially dissolves, and something entirely different assembles itself from what remains. When the butterfly finally pulls free, wings still creased, still finding their shape, the change feels less like biology and more like a conjuring trick seen too slowly to quite believe. Not every transformation is so dramatic. Some insects simply arrive already looking wrong for the world they inhabit. The jewel beetle carries a surface that catches light the way polished metal does. Shifting, iridescent, belonging more to a display case than a forest. On a piece of bark, it looks like something someone dropped. Others invest in concealment of a different kind. The young spittlebug builds itself a small fortress of foam produced from plant sap that hides it almost completely from anything passing by. From the outside, it looks like a bubble of nothing. From the inside, it is apparently sufficient. The Atlas moth takes a different approach to its brief adult existence. With a wingspan that can exceed a human hand, it emerges from its cocoon already committed to a life without feeding. No functioning mouth, no time for it. Everything it needs was accumulated before the wings unfolded. It has, at most, a few days. It uses them. And then, there is the vinegaroon, which looks, at first encounter, like something assembled from spare parts. The claws of one animal, the tail of another, the general unsettling presence of something that hasn't quite decided what it is. When threatened, it releases a spray with a sharp, acidic smell, the source of its name, and a surprisingly effective argument for being left alone. Most of it unfolds where we rarely think to look, beneath bark, inside stems, across the surface of a pond at first light, a world that has been running continuously in one form or another since long before anything resembling us appeared on this planet. It did not wait for an audience. It does not require one. What we've seen here is a fraction, a brief window left open. A spider, mid-leap, already certain of where it will land. A bee returning to a hive that somehow knows what to do with the information she carries. A mantis, motionless for so long it has become part of the plant beneath it. These are not exceptions. This is simply what the world looks like, one layer down. The insects do not rest. Season after season, the same ponds, the same trees, the same stems, occupied by something new that behaves exactly like what came before. The individuals change. The work continues. We tend to think of nature as something out there, somewhere beyond the edge of the city, requiring a long journey to reach. But step outside and look down. Look closely at the nearest patch of grass, the bark of the nearest tree, the surface of the nearest still water. It was there the whole time.